Okay, so week 10, we're talking about sizing wires, and we're talking about voltage drop. And we said we always want the voltage to be within 10% above or below the nameplate. So the maximum for branch size, what is a branch? That's if you are connecting equipment in parallel, that's a branch. The drop for branch is 3%. Yeah. For the main line, it should not be more than 10% for the main line. So if we look at the stuff in the quiz here, if you look at the main line is the one coming to the whole equipment. If you look at inside, that's the branch. That's for the compressor, the fan motor, etc. And if you go into non-packaged ACs, probably you will have to wire these things individually. You'll wire the compressor by itself, you'll wire the condenser fan by itself. It's not all packaged with one wire. So you probably have to do your own individual wire. Any questions about voltage drop? And again, when in doubt, measure. Your multimeter is your best friend. You go and measure how much voltage is there, and it's good to take some diagnosis. It's kind of the same thing when you go to a doctor. The first thing they do is what? They set you down, look your temperature, and vital signs. You want to do the same thing when you go to an equipment. Measure the voltage, measure the frequency, measure the amperage. That will be the first thing that you will do. Again, all wire sizing charts are based on National Electric Code. So when in doubt, you always consult with the code. So usually, all conductors and all wires are sized within range, unless it's extremely long, and that's what happens usually with air conditioners when you have the condenser placed outside. Where do we usually put out the condenser? Either outside in the yard, or sometimes Louis said in the roof. Put in the roof because you want to be outside, exposing hot air to the atmosphere. Sometimes in big buildings you see them hanging.
Yeah, I've seen that through the old people place.
But it has to be outside. So you always have the ADC with you for reference. You can always access it online, and if you have all the charts with you. So for the formula, E here is voltage, current times resistance. We said this is my voltage, this is my amperage, this is the resistance. And again, if the resistance increases, the voltage will drop. Where would you find the amperage drop? The estimated average drop of the equipment usually is printed on it. We saw in the lab when we did the transformer testing, it should say on it what amperage draw they expected to have. This one has 2.2 amps. So if it's drawing 1.8, what does that mean? It's not functioning the way it's supposed to. Something is wrong with it. If it's drawing 2.5, again, that's not supposed to happen. Something is wrong with the equipment. It should not be that much. So 2.2, if it's around 2, around like 10% plus or minus, probably you're okay. So that's something you want to pay attention to. Where did I go?
I'm gonna go back.
Yeah, right there. Yeah, voltage drop. So usually, okay, it's feet and meters. You will not exceed 75 or 100 feet within the source of the power. And again, that will be in the installation guidelines. I'll tell you, okay, this equipment was sized and designed to be 100 feet from the main source of power. So you'll go measure the main source. Again, the main source probably a few feet away from the control panel. So you always measure the voltage drop. And every time, remember when we did the resistances in series, and we went for after the first light bulb and we saw some voltage drop, or was like 40 volts or so. So again, the wire is connected in series, so it will cause some voltage drop. So 75 to 100 feet, any more than that, then probably you will have to change the wiring. And the 100 feet is like 30 meters. That's not that. That's far. That is pretty far. Disconnect switches. That's a very important piece of information. No, it's not. You do not put disconnect switch on the neutral. Always the hot. Same reason why we don't put fuses on the neutral, because we are trying to protect the circuit, and the neutral is the line coming back, so it doesn't make sense to put things on the neutral. So if you look at a disconnect switch, the fuse lines are the hot lines, whether they're one phase or three phase. So some of them are fusible, some of them are not fusible, depending on what are you going to use it for, and what is the recommendation for that equipment. Sometimes with large compressors, you do not want to use fuse. Why? They account for the startup for the compressor that might spike the power, and if you have fuse, you'll burn the fuse every time you try to start the compressor after a long time of rest. Do you notice that sometimes you have a pump, a water pump, an oil pump sitting for a long time? When you turn on, it's not going to turn because it's been sitting for a long time. So sometimes it will spike a lot of power. So if we have a compressor that has not been running the whole season, then we try to turn it on, it might burn the fuse. So check with the recommendation for the fuse whether it's going to be requiring a fuse or not. Fuses provide overcurrent protection similar to a circuit breaker. It can be general duty or heavy duty, depending on the amperage. Some of them are expensive fuses. These ones, you can replace the filament inside because they're heavy duty, meaning the glass is made that is tempered so it doesn't break. Whatever material is around is resistant to the shock and heat. Okay, enclosures, general type used for where there is no moisture, dust, or explosive fumes. These are the enclosure for disconnect switches and also for the wires. So this is general type, and it will say on it, it pass this box around, last class. Rain tight, these are for outside. So if you are going to put an enclosure for a compressor outside, you want to make sure it is rain tight, and also airtight sometimes. What happens when you place these outside, a lot of insects like to build nest in it, and they will be around the fuses. So make sure it's rain tight, so it does not build or oxidize. Have a lot of moisture. Huh? Bees, wasps, and moth, they can get inside. They like the warmth. The wires are very warm, so they'll go inside. Yeah. So that's something you wanna check. If it's outside, it has to be rain tight. Explosion proof. These, of course, they can be used anywhere, but they're a little bit more expensive. Where would you find explosion proof boxes and closures? Huh? Power plants, yes. Power plants, refineries, places where they have a lot of gas and there's a possibility of an explosion. You want all these to be, all the enclosures coming from the disconnect switch, the equipment to be explosion proof. Why? So in case there is a small explosion or even an explosion, it would not tear away all the wires and disconnect and exasperate the problem. Fusible and non-fusible. Non-fusible disconnect switch used normally to break the power supply. It doesn't do anything besides that, just on and off. The fusible ones, they have fuses, so they can also act as a power protection in case there is a surge or overload of power. Questions so far? So these are fuses, and these are for the hot line. So probably this is 240, 110 and 110, and this is my neutral. And this is three wire, two fuse disconnect. This is the 4 wire, 3 fuse disconnect. So it probably is 3 phase. So fusible load center. Probably if you go to a power plant, if you ever worked in a power plant or any kind of factory, they have a control room where if all the equipment is connected to that control room. Why?
So you know that if you need to turn it all off, it's everything. Just shut it off.
Yeah.
And to know that if you detect something wrong, then you know.
What are you doing?
happened right here.
Give it a remote.
No, it started long upstairs, it's not turning on.
Give it a remote, don't you? You broke my AC.
Yeah, put your face.
We're gonna put it there. You have most of your remote privileges.
Damn, it seems like John Wick.
So, what I was asking, usually when you go to,
Continental privilege.
focus a little bit. If you go to a power plant, if you go to a refinery, usually they put all the disconnect switches in one room for accessibility. So you want somebody to be in the control room to be able to shut off on and off each equipment if they need to. You cannot be running around the house and around the plant to turn things off. You want things to be centralized so you know what power to shut off.
Yeah.
Same way we have those control panels in one place, so you know where the control panel is and you can go and shut off every equipment. So it's a good idea to have things to be centralized and labeled. So if you have your disconnect switch, if you go to install a boiler or an AC, if this control panel is not labeled, you cannot find the label for your disconnect switch. Well, this will connect to a disconnect switch into your AC at some point. Label the control panel because this is going to be more accessible than this disconnect switch. Where would I have the disconnect switch?
Outside.
Outside, next to the compressor,
Yeah.
very close to it. So it's really difficult to go and find the disconnect switch outside. It's easier to go to the control panel and close the disconnect switch. So that's why we try to have them all in one place. Non-fusible, newest fusible control center, they have fuses. Some of these control panels also can have a fuse in them for extra protection. These are breaker panels we saw over here, and they have breakers in case we exceeded the power usage. All this information is in the book and it's in PowerPoint. You want to go back? How they're built, we don't need to know much about that. Okay. Another piece of information. Do we install this?
No.
No.
Went for the license.
Certified electrician should install this. This should be next to your equipment, and you can connect your boiler or your AC to the control panel. So make sure that whoever installed that is a certified electrician. Take the name and information, and you can check the gauge of the wire all the way from the disconnect switch to the control panel. Make sure it's the correct information. If you have equipment that exceeds the gauge required, you cannot request the wires to be changed before you install your equipment. This is a combination of all these disconnect switches. If you work in a power plant, you will see all these disconnect switches, and they are labeled. That's for the operator to go turn on and off equipment, and all of them are fusible or have circuit breakers. And nowadays they have control panels with computers which will give you information about which equipment is on or off, what's happening with the equipment. Most of the commercial and industrial applications. Also in some big commercial buildings, like housing buildings with so many building complexes, some of them actually have control panels to tell you the consumption for each unit. A lot of them also have, what do you call it, smart metering systems, tell you what is the consumption for each unit in terms of gas and electricity. And repetition, same thing. Same thing. So, again, just to repeat, if you look for your installation for heating and cooling, even if you have a heat pump, what is a heat pump? It's an AC that can be reversed and can produce heat. You will still need a furnace as a backup heat. Until now, you always need a furnace for backup, usually during the very cold months of January and February. So you will have your load center here, which is a control panel. The furnace will be close by, so it's not a lot of wiring. The issue you will have is with the air conditioner, where you have your compressor outside and condenser. So you'll have a disconnect switch next to the equipment. So if somebody runs off and sees something on fire or it's making a lot of noise, they can come and shut it off. And again, remember from the first class ever, you cannot, if you notice there are no holes here, so you cannot lock this in the on position. You can only lock it in the off position. So anybody, for example, somebody walking on something from the outside and they saw some spark or it sounded really loud or something is off with the compressor, they can come and shut it off, or you want to go and check what's going on. And again, because the condensers is outside, so anything can happen. Some people go through the extent of building a shelter for the compressor to protect it from leaves coming in or animals, but sometimes it's not. So it's good to have a disconnect switch close to it. This one here, if it's within 100 feet, it should be okay. It should be included in the design of the voltage drop. If not, probably you should double check. And if you have high voltage drop, what is the first option you can do? You can call an electrician to change the wires, and what they will do, they will put a bigger gauge. Bigger gauge means less resistance. So probably you will have less voltage drop. Do you remember that two wires of the same length? Which one has more resistance? Small one. More resistance. This is less. And if we have a long one, it has more. Always think of a pipe. A big pipe has less resistance than a small pipe. Think of pipe and think of the current as being the flow of water.
And the pressure too.
The pressure is equivalent to
The
voltage.
Yeah.
So
Because a big pipe, when you don't have like more water, it's
Yeah.
it's not that much resistance. Just go for it.
again, check your fuses. Many times you will go to an AC unit outside and you look at a three-phase connection and one of them is gone. So you can go and check the voltage in each one of them, and probably Bill gonna have you do troubleshooting in one of those ACs next semester. One of the things we do is we put a bad fuse in there, and it's for you to go and check the fuses. First, turn it off, take the fuses out. There's a tool that you use to take the fuses out. Do not use your fingers. Do not take it with your hand in case there's voltage. You take it out and you check the fuse. How do you check the fuse?
With each end with the multimeter.
Yeah. What do you say the multimeter on?
Continue.
Either continuity or
Oh,
resistance.
Aren't they sometimes clear and you can just see if it's popped?
Not the heavy duty are covered. They
Oh, they are.
Yeah. So it's very tough. So this is your disconnect switch with fuses in it. And if you look here, you see some information. How do you check those boxes? So far we covered in this chapter American wire gauge, AWG, and there's a guideline in the book on how you check and pick the right wire, and they are numbered. So they tell you to use a number for that wire. Use the exact number. Do not deviate much from that. Breaker panel, disconnect switch, distribution center. That's usually in a big plant. We have two many equipment. Fusible disconnect switch. This is fusible. Has fuses in it. Fusible load center, NEC, and non-fusible disconnect switch. I don't know if they have one, but they just don't have any fuses. Just to repeat what we said on Monday, this is how we calculate voltage drop. The maximum recommended voltage drop for branch is 3%. A branch is when you go from the main line, so 3%. And for the main line, it's 10%. So 10% from the power source, 120, all the way to the equipment. It shouldn't be more than that. If it's more, the equipment might not run correctly, and you might want to consult with the electrician. So that covers up chapter 8. Chapter 9 and 10, they will talk elaborately about motors because they're very important. And we'll spend 2 weeks talking about motors. And after that, we have relays and contactors, which something goes to a lot of repetition. What's after that? Contactors, relays. Then it will go into pressure switches and thermostat, and we'll cover that also last week. Okay?
It is okay.
That's all.
We're done?
Yeah.
I was actually gonna go get food.